Good afternoon, everyone. We are presenting our topic on text summarization in NLP, from abstractive to abstractive and beyond. I'm Sindhuja, and along with Mahesh and Ashirwad, will walk you through how computers are learning to summarize text just like humans do. So we'll keep it simple, interactive, and interesting. So let's get started. Let's begin with the basic question: what exactly is text summarization? So imagine you have got a 10-page research article to read before the class, but you only have 5 minutes. Would you want a short version tells you everything important, right? That's how summarization works. So it condenses long text while keeping the main ideas intact. There are two types of summarization, which is extractive summarization, which picks out the most important sentences from the text. And second one is abstractive summarization, which rewrites the content in new words, like how we explain something in our own way after reading it. Next is why summarization matters. Why is that even important? We are constantly overloaded with the information like news, research papers, emails, and social media posts. No one has time to read it all. So summarization helps reduce this information overload. It saves time, boosts productivity, and supports quick decision making. So for an instance, in media, it used to generate short news updates. In business, to summarize meeting notes. And in education, to summarize lecture or research papers. Even apps today use AI to summarize podcasts or YouTube videos into key bullet points. So that's how the powerful it become. Next is types of summarization. So there are three main types of summarization. First one is extractive, which selects key sentences. Second one is abstractive, which rephrases ideas using new wording. And third one is hybrid approach. It combines both for better result. So think of extractive as highlighting text in a book and abstractive as summarizing it in your own words. So for an example, if our original text says the stock market declined by 2% due to inflation concerns, an extractive summary might copy that same sentence, while an abstract summary might say inflation worries caused a small drop in the stock market. This how the types of summarization works in an into the next slide, which is extractive summarization in detail. Extractive summarization works using algorithms like TF, IDF, XRank, and LexRank. They score each sentence based on importance and select the top ones. The good part is it's simple, fast, and preserves accuracy because it uses real text, right? And the downside, it can sound robotic or disconnected because it just copies chunks of the original. It's like copying notes word to word from a textbook instead of writing them in your own way. So while it's good for quick summaries, it doesn't sound very natural. And that's where Mahesh will take over to explain how abstractive summarization tries to fix this.
Okay. Hi everyone. Thank you, Sindhuja. Hi everyone. My name is Mahesh Babu Pallapolu. Now I'm gonna start with the abstractive summarization. Mm, we can see that. Now let's talk about extractive summarization, the more human-like version. Instead of picking sentences, it understands the meaning and then writes a new concise version. It's powered by neural networks, especially encoder, decoder architectures and transformers that generate sentences which flow naturally. The results sound smooth and reliable, like human wrote them. However, training this model is complex and sometimes they make things up. We call that uh, hallucination. For example, summarizing a movie review and adding a fake plot twist. Oops. Uh, we go to the next slide. Next slide is about sequence to sequence and attention models. These are the some of the evolution of summarization models. Uh, Before transformers became popular, summarization models used sequence to sequence models, often called sec to sec. Uh, the encoder read the text and the decoder generated the summary word by word. Then came the attention mechanism, which was a game changer. It helped the model focus on the most relevant words, almost like how our brains highlight key ideas while reading. This made summaries much more meaningful and context aware. We move to the next slide. The rise of transformers, how transformers changed the game. Mm, we can see that the rise of transformers, then came the star players transformers. Transformers introduce something called self-attention, which allows the model to understand relationships between all words at once, not just nearby ones. This lead to models like BERT, T5, BART, and Pegasus. They could understand the whole text globally and generate summaries that were coherent and fluent. Imagine reading a long article and instantly knowing, sorry, instantly knowing the matters most that what transformers do. Uh, we move to the next slide. These are some of the real world examples or real world applications. So where do we see all of this applied? Almost, I think in almost everywhere. It's in media, summarization tools create short news digest. In healthcare, they help doctors condense long patient histories. In business, AI tools automatically summarize meetings. And in education, summarizers help students shorten research papers or lecture notes. It's even integrated into tools like Gmail and Notion, where you get quick summaries of conversations or documents. So next time your app gives you a quick summary, that's NLP at work. Now we are moving to the next slide. Challenges in summarization. Transition to LLMS.
Thank you so
I'm
much, Mahesh Babu.
oh,
Thank you so much. And myself, Ashirwad Polumuri. And let's discuss about the challenges in summarization. While these models are incredible, summarization is not perfect yet. And the biggest challenge is faithfulness, ensuring the summary does not add false or misleading information. Then comes to evolution. The metrics like ROG or Blue E only measure similarity to reference text but can't tell us if the summary is actual good. Long documents are also tough. Many models still lose the context after a few thousand words. But coming to the multilingual summarization is even harder because low resources languages lack enough training data. So let's move to the slide. Next slide. Yeah. This slide, we can speak about the data sets and evolution metrics. To build the summarization models, we need large data sets. So, some popular ones are CNN, Daily Mail, XM, and Gigaword. This contains thousands of human written summaries. Metrics like row, Bluey, and metric score are used to compare model summaries with the reference ones. But honestly, human evolution is still the golden standard because only humans can judge readability, flow, and accuracy. If the model writes something fluent but wrong, only human can catch it, right? So let's speak about the next slide. This slide covers about the multilingual and domain specific summarization. Now let's look a multilingual summarization. Never, newer models like MT5 and MBOT can handle multi languages, summarizing across English, French, Spanish, and more languages. But there are also domain specific summarizers trained or legal, medical, and financial documents. Since those fields require high accuracy, for example, in medical domain, summarization must never lose critical patient details. So, models are fine tuned for precision and readability. So let's move to the upcoming slide. Yeah, this slide speaks about the role of LLMS and beyond abstractive. Today's LLMS are capable for more than just text summarization. They can summarize audio, video, and images too. This is called multimodal summarization. For example, image uploading a full recorded meeting, the AI can generate a summary showing who said what and the key decisions and the next steps. We also have the interactive summarization where you can ask follow-up questions like summarize this in bullet points or explain this part in detail. It's like having a personal assistant who understands your performances. Let's move to the next slide. Yeah, and this slide covers about the future directions and the conclusion. So, what's next? The future of summarization is moving toward hybrid extractive, abstractive models, fact aware summaries, and ethnical summarization, meaning ensures summaries are truthful, unbiased, and privacy respecting. We are also seeing personalized summarization where AI adjusts the level of detail and tone based on who's reading. A student might get a simplified version where a researcher gets the technical one. So, to wrap it up, summarization has evolved from extractive methods to abstractive and now intelligent LLM driven approaches. It has the one of the best example how AI saves us the time and helps us to make sense of massive information around us. And thank you so much for listening.
Uh, Before we wrap it up, I would like to take a moment to reflect on what summarization really means in today's world. We live in an era of information overload. News articles, research papers, reports, and online contests are being generated faster than we can possibly consume. In this ocean of data, summarization isn't just a convenience anymore. It's a necessity. It helps us extract meaning, prioritize what matters, and make better, faster decisions. The journey of summarization from simple rule-based systems to the advanced LLMs we see today shows how far AI and NLP have progressed in understanding human language. What once took terms of editors or analysts can now be done in seconds by intelligent models that understand context, tone, and even emotion. In short, summarization isn't just a technical challenge, it's a bridge between information and insight. And with every every advancement, we move one step closer to a world where information truly empowers people rather than overwhelms them. Thank you all for your attention, and I hope this presentation has shown you how far we have came and how exciting the future for summarization really is. Thank you so much.